Today we are trying to solve the question, uh, LeetCode question number 205, isomorphic strings. Given two strings S and T, determine if they are isomorphic. Two strings S and T are isomorphic if the characters of in S can be replaced with T. Basically, if at whatever places where so the basic um, idea for the question is that if you have P, you can replace instead of T, if you put P, it'll work. Instead of I, if you put uh, E, and instead of L, if you put E, and instead of R, you put E, you get paper can is isomorphic to the title. Basically, the same type of character, if placed in the current place, it can change the whole. Then you can say that the both strings are isomorphic. So how about you go solving this problem? So our condition is we have to check whether these two are um, isomorphic. Um, so how do we do that? So to do this, we have a one more thing called ooh, private string transform string 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 s. In transform string dot string s, what we do is uh, we initialize a dictionary char comma int uh, stick is equal to new s dictionary. Okay. After that, we create a string builder. String builder sp is equal to new string builder sp. Okay. What do we do is for int I equal to 0, I less than s dot length I plus plus. So we go through the whole position. We get the character c is equal to s dot I. It's a current character at that position. Then what we do is we check char if sdict contains key c. If it contains key, what we have to actually check is if it doesn't contain key, we do csdict c is equal to I. We are storing the first time when we find that character in the string. So yeah, for each and every we are trying to find it. Once we do that, what we do is we have to sb dot append. We append the sdict dot c to string. Basically, we are converting the int to char. Then what we do sb dot append space. We are just giving a space. Once we do that, return sb to string. Basic idea is that we go through the whole uh, string whenever we find a character, and if we find it for the first time, we assign that character with the first index where we found it. So in our own custom version of the string, what we do is whenever we find that character, we take that character, instead of that character, we append the first index position where we found it. So those index position would be the first unique position. So that would, and then we would give some space between those so that if it is like index 1 and 2 and 12, to get that distinction, what we do is we give a space in between and we return the string. So how do you say is my isomorphic? The way you say is that return transform string s is equal to transform string t. Right? Yeah. So that should most of it means that while once we replace the all places where we find the character as in the index, if the index positions of the replace are same, then we will most probably get it correct. Let me quickly test this out. Okay, this was 205, right? Yeah, it's test and check. Yeah, seems to be passing. So yeah, the isomorphic string paper and title seems to be passing. You can debug this and check also. Let's assume what we get out uh, from here. Okay, when we debug and test, remove this piece. Let's see what it is. Okay, SB. Yeah, okay. So yeah, it seems to be working. Now let me paste it and check in public. Okay, save this, copy this. Uh, we need the solution, right? What we'll do is, yeah, save this. We run this. Seems to be working. To string window. Now let me submit it. Okay. So yeah, it seems to be working and it passes.